You know, our solar system is one of many. One star, the Sun, the planets, Venus, Mars, Jupiter and the rest, and of course our own Earth. Are there other solar systems? Surely the answer is yes. With me, two experts, Doctors Chris Lintott and Lewis Dartnell.
Evening, Patrick.
First of all, what do we think about finding other solar systems?
Well, the first thing I think, Patrick, is that it's incredibly difficult. And for hundreds of years, people have speculated that there might be planets around other stars, but we haven't had the tools we've needed or the techniques we've needed to go after them until recently. And the key, it turns out, is to look very closely at the stars themselves. And the first method that was used to discover planets is called the wobble method, the radial velocity method. So I think I'm going to demonstrate this by picking up the Sun over here, which is something we can only do on the sky. And actually, this isn't the Sun, this is a distant star. You've got a big, juicy, gaseous planet there. What I want you to imagine is that this planet is orbiting the star, and what's happening is that the star's gravity is pulling on the planet, but the planet's gravity is pulling on the star. And so the star is drawn towards the planet, and so we get this slow wobble back and forth as the planet moves. Now, it's not a very big wobble. In our solar system, more than 99% of the mass is in the Sun, but it does wobble nonetheless at about walking speed, a few meters per second. And by looking at the star's light, by looking very carefully at the light we get from the star, we don't see the planet, but we do see this wobble. And then we can detect that there's a planet there. And Lewis, we can find out something about the planet itself.
We first discovered a planet orbiting a main sequence, a normal star, back in 1995. And so today we are very much in the golden age of discovering new worlds orbiting other suns in our galaxy. It's like being back in the 1500s and discovering new continents. We're discovering new worlds now.
And so the first planets we found were these hot Jupiters, very, very close to their parent stars.
We have started to read the chemistry of some of these extrasolar planets' atmospheres,
yes.
and people have spotted the signature, the fingerprint in the spectrum and in the kind of colour of the light coming from the planet. They've detected water vapour and carbon dioxide and methane. So the beginnings of chemistry and characterising what these planets are like.
Those are three things needed for life.
What about Jupiter's moons, though? Because if you put one of these hot Jupiters and it has moons just like Jupiter or Saturn do, maybe they're worlds where life can exist.
Exactly, so you need the right kind of world to host life. Perhaps a rocky world like Earth, or maybe an icy world with a molten ocean, a water ocean beneath it, something more like Europa. But it's not just the kind of world you need, but the location of that world in its solar system. So we can perhaps demonstrate this, keeping with our Sun that Chris has got there. I'll pick up our Earth. Now, our Earth has a particular orbit around our Sun. It's an orbit that takes 1 year, and it's a surprisingly circular orbit around our Sun. But the distance of the Earth away from the Sun is very, very important. It's the right distance from the warmth of the campfire, that the temperatures on Earth are just right for life. And if the Earth was closer to the Sun, perhaps like Venus or Mercury, it would receive too much heat.
There you go.
Its oceans of the Earth would have boiled away. It would be a hothouse, greenhouse world like we find Venus is today. If the Earth, in fact, had formed further from the Sun, from the heat of the campfire, it would have frozen. It would have frozen over and become like Mars.
Come to Mars.
So Earth is kind of in that sweet spot between being too hot and close like Venus and being too far away like Mars. And Earth orbits in this magical region, this ring around every star. And you can calculate it for different kinds of stars, where the temperatures on planets orbiting within that zone, within the habitable zone, would be conducive for liquid water and therefore possibly life. And it's those kind of planets we're most excited about trying to find.
And in fact, we've just found one. So
the
first planet in its habitable zone has been, to be properly confirmed, was announced just a few weeks ago. So that was Kepler 22b. Terrible name, but never mind. And that was found by a different method called the wink method. So, well, maybe I'll be the Sun again.
Yeah.
Imagine this Earth-like world is Kepler 22b.
And it can orbit in different ways. And you can imagine that with any solar system, just like our own, you have all the planets orbiting in a particular plane. Just by chance, some of these alien solar systems will be inclined and angled directly towards us from our telescopes on Earth. So you'd see it orbiting around like this. And so from this point of view, you can see the planet passing in front of the star, blocking out some of its light as it transits or kind of creates an almost mini eclipse of that Sun. We know its radius, we know its size, we know it's just over twice the width of Earth. We don't know its mass. We think it could be up to 30 Earth masses if it's quite gassy like Neptune. In a best case scenario, it might be all the way down to 10 Earth masses. So it's still a super Earth. It's still a very massive, heavy planet compared to our home world. But if it's a water world, if it's covered with more ocean and less rock, then it might be down to 10 Earth masses. But it still have substantially greater gravity. You probably, if there was life here, you'd be on an ocean world and to be able to support a lot of your weight, perhaps as a whale with kind of the water buoyancy, taking all of that weight that the gravity's pulling you down with.
It's a wonderful thought, isn't it? The whales of Kepler
Alien
22b.
worlds, yeah.
Well, I have to say, I get sick of remembering catalogue numbers. I mean, Kepler 22b I can manage, but Gliese 581 B, C, D, and E.
Enough for asteroids.
Exactly. People named asteroids. There are plenty of those. Would you name extrasolar planets, Patrick?
I would, yes.
Yeah. What would you call them? What's your first nomination?
Nemo.
Nemo. Why Nemo?
The unknown.
Oh, okay. I like that. I'm going for Chris. I think would be good, and Lintott would be a good second one.
For its moon, maybe.
Yeah, sure. But the point is, names are memorable, and these are worlds.
Exactly.
Out
There's
there.
a whole world. There's a lot of imagination, and they've got their own climates and atmospheres.
Actually, we should talk about, because I know whenever we talk about extrasolar planets, there's something slightly unsatisfactory about the fact we can't see them. We have all of these methods. We've got the wobble and the wink, but there's no real substitute for seeing these things. One of my favourite results from the last few years was the first images of extrasolar planets.
I agree on that.
In orbit, particularly, I don't know if you can remember, do you remember the Fomalhaut picture?
I certainly do. It almost like the Eye of Saruman.
The image looks odd because you've got to mask out all the light from the star. But then you can see this tiny speck, and then you can see it move over years. And for me, that's real. That has to be real.
I always said that I believe in these things once we saw one. And now we have.
That's right. Well, Patrick, we've been talking about these marvellous discoveries from the Kepler spacecraft, and just a few months ago I caught up with Bill Borucki, who's the man behind it, and he was fascinating. Since 2009, the Kepler spacecraft has been staring at a small patch of sky, monitoring 150,000 stars. It's looking for tiny dips in light as planets pass in front of those stars, and it needs 3 of those winks to be seen before the team can be sure they're onto something. Bill Borucki is the leading light of the Kepler mission and is proud to have discovered a multitude of worlds, some normal, some exotic and strange. I caught up with him at the recent planetary conference in France.
Of course, we have a lot of candidates, and we go through a lot of processing to make them announcements. But the ones that we've announced as firmly as planets, I think some of my favorites are the fact that we now have one that has 6 planets orbiting it, transiting it. We have one where the planet orbits a pair of stars, just like in Star Wars.
Oh, yeah.
Okay? So you see 2 stars and sunrise, 2 stars setting and sunset. Because in Star Wars, you see Luke Skywalker looking off at the distance. You see these 2 stars setting on the horizon. What Lucas got wrong, of course, was he made the blue star small and the red star big. Just the opposite's the case.
Okay.
The blue star is big one, the red star is small and dim.
Excellent.
So we've talked to him about that. He said he'll try to get it right next time.
That's rather nice. We could begin to think about how many large planets there are and how many Earth-like planets there are. Do we have a sense yet of which are more common? Is a typical planet like Jupiter, or are there more small rocky bodies?
All the evidence that we have is that the Jupiters are rare. The Neptunes and the planets that are sort of supersized Earths seem to be much, much more plentiful, like 10 to 1.
Okay, and so that would be from a few times the size of the Earth.
When you think about these objects, you're really asking, are they rocky?
Right.
You know, because if the planet's a gas planet, even though it's fairly small, there can be no surface. And we don't think there's any life because it's hydrogen. Anything heavier than that.
Might have moons, though.
It might have moons. And so that's interesting. We're finding a fair number of Neptunes and Jupiters that are in the habitable zone of their stars. But we don't think to be life on the planets, but if they have moons, the moons are around the planets, and therefore they're in habitable zone. And so you could imagine that you had a Jupiter in habitable zone and had 3 or 4 moons like our Jupiter does. They're all the size of the Earth. They have atmospheres. They have people on them. They go from one place to the other for vacations or to visit relatives and so on.
Do you have a sense of when we will have a good sense of what the population of planets out there?
We know we still haven't got to the point where we're finding Earths in the habitable zone. We don't have a lot of confirmed objects in the habitable zone, so we certainly need more there. But you know, people sometimes say, well, you've found quite a few Jupiters now. Don't you have enough? It's something like asking Darwin You've seen one finch, haven't you seen them all?
Yeah, whereas it's actually the variety is the point.
The variety is the point. Those differences tell you about their formation, their structure.
Well, in the meantime then, more finches, and I hope you'll come back and tell us about them. So thanks a lot.
I look forward to that. Thank you.
My pleasure. Kepler has recently found Kepler 20e and 20f, two rocky planets orbiting the same star, each roughly the same size as Earth, but neither of them in that magic Goldilocks zone. As the mission rolls on, discoveries like these means it's just a matter of time before Kepler finds a planet like Earth, not too hot and not too cold, and then the hunt will be on to see if there's life out there.
We've been talking about other planets, but how are they formed? Well, now, with me, the two Chris's.
I think, Chris, we have to start with star formation, right?
Yes.
Because before you form planets, you've got to form the star.
Yes, so a star forms from a huge cloud of gas and dust and the stuff that's out in space, and over tens, hundreds of millions of years, that collapses down just by gravity. And in the end, the density and the temperature get so hot in the centre, you form a star. But that's just in the centre, because you've still got this entire cloud of stuff around it.
I think, if I'm right, the tricky bit is going from dust and gas all the way up to nice, beautiful planets.
So I'm going to give you a wooden spoon.
Okay.
No insult intended, but
No, that's fine.
Would you please stir the bowl in a nice, even manner?
Okay.
So what we've got here is that the water in the bowl is the disk of gas that is orbiting the star.
About the right speed?
That looks about right, yeah.
Okay.
So we have here some pepper, and the pepper is going to be the dust, and we shall see what happens. So, if you take the spoon out.
Okay, so the water's the gas.
So the water's spinning. I'm just going to sprinkle some pepper on there, and very quickly the grains of pepper group together into clumps.
They sort of do, don't they? It's a bit Spiral Galaxy-esque. What
happens to a protoplanetary disk, as we call them, is not too dissimilar to what happens in a disk of gas and dust in a galaxy.
So why is the pepper clumping together?
So the pepper clumps because the tiny grains actually stick together.
Okay.
And in a similar way to little grains of dust in a solar system stick together.
Chris and Chris, thank you very much. We have planets on view this month that we still have. And Pete and Paul are waiting outside to show us Jupiter.
Well, Happy New Year, by the way.
Thank you very much, Paul. It's a bit of a wet, windy one and rather cold as well.
I was hoping we'd see Mars and Jupiter earlier, but I'm not sure now.
Well, I've set up a pot of tea in the observatory, so we can sit in there and wait and see if the clouds do part for us.
Aren't you a good chap?
I am indeed.
Well, some interesting things happening this year, Pete. We've got that transit of Venus, and of course we have some good meteor showers this year, because the moon's out of the way.
I'm really looking forward to the meteor showers, actually, because they have actually been ruined this year by the moon being in the way, as you say.
They have, they've been quite awful.
But we've also got the sun, which is waking up at the moment. It has looked quite exciting, and there's been lots of prominences and flares and things going off. Now that's quite exciting, because if it carries on building throughout the year, that gives us a chance of seeing an aurora.
Yes.
So let's start off with the planets, and let's start off with the very first planet, which is Mercury.
Yes, a difficult object to see, actually, especially from cities, because it's always really rather low down.
It said 1% of the population have only ever seen it, and I don't think that's true, because I think...
Probably much less.
Well, we pointed out month after month, but during January, it can be seen in the first part of January in the early morning sky. If you look to the southeast, just before sunrise, then you might be able to pick it up.
Now, Mars is at opposition in March, so it is then visible all night and well placed for being able to see it.
It's actually not too bad, because it's not moving about a lot in the sky. It's actually very close to the rear legs of Leo the lion. It looks like a bright orangey star. You get that rather interesting appearance to Mars, because one of the most prominent dark features on the surface, that V-shaped dark feature, the Syrtis Major, which actually I think always looks like a pair of white fronts.
Says a lot about your imagination, Pete.
Possibly. Well, let's carry on out of the solar system now and go out to the next one, the biggest planet in the entire solar system, Jupiter.
Still blazing away in the sky.
It's been magnificent, hasn't it, over the last few months? But there's still plenty to be had with Jupiter.
There is.
It's actually in Aries. In fact, I think it flips over into the neighbouring constellation of Pisces, just jumps over the border this month. But with the naked eye, it looks quite stunning. A pair of binoculars, you can make out those 4 bright moons, the Galilean moons, which dance around the planet.
Indeed.
And then with a telescope, you can make out all manner of detail.
Well, let's move on now to one of my favourite planets in the entire solar system, and that is Saturn.
Yeah.
Now, as you remember, last year there was that tremendous, phenomenal storm on Saturn. We'd never seen anything like it, really. Really, this enormous outbreak, and it appears it's still going.
And the easiest way to find it is to use that very familiar pattern of the plough or saucepan. If you follow the curving handle of the saucepan round, you come down to a really bright orange star, which is known as Arcturus. Carry on going, and you end up at Spica, and Saturn is right next to Spica at the moment.
In the constellation of Virgo. Plenty to look at in the night sky of January, Pete. We must have tea in the observatory more often.
I think it's getting cold, actually.
Let's try it.
And now for our news notes. Chris, what's happening in the universe?
Well, let's start close to home as ever. Let's start in the solar system with Vesta, where we've got these amazing images coming back from the Dawn probe, which has been in orbit now for a few months. And in fact, it's just reached its lowest orbit, which is just 130 miles above the surface of this tiny little world. And Vesta turns out to be quite an interesting place. But I think the most remarkable thing is down here near one of the poles, this giant mountain, nearly as big as Olympus Mons, one of the largest in the solar system on such a small world. And I don't think anyone was expecting that, were they, Chris?
No one thought about that.
I was lucky enough to speak to Chris Russell, the lead scientist of the Dawn mission, back in October. The Dawn spacecraft went into orbit around Vesta in August 2011 and is giving us a unique view of the solar system's second biggest asteroid. I caught up with Professor Chris Russell at a recent planetary science conference. Chris is in charge of the mission and is loving the surprises that Vesta is throwing at us.
We've learned that it was really a good place to go to, and that's important to me because what we're trying to do is to go back in time and to learn more about the earliest epoch of the solar system. So did the surface record all these events? And we believe when we look at the surface that it's been a good recorder.
So this impact crater is about the same size as Vesta itself, right? Its diameter isn't comparable to that of
Right. Well, it's very large. We're trying to understand things like what is the age of this structure? Is this structure more recent than the other surface or not? We haven't quite figured that out yet because there are some areas on there that don't look like they have enough craters.
But in general, surfaces with fewer craters are considered younger.
And then the ones with heavily cratered are the old ones. And we think that we can use the cratering record to figure out how old the surface is.
Craters expose what's underneath the surface, and the fresher the crater, the better. Looking at craters on Vesta is our way of seeing what the solar system was made of 4 billion years ago, and seeing something for the first time is always exciting.
Every time you see something with higher resolution you've never seen before, you're surprised. Your imagination is great, but you can't really imagine what the surface is going to be like. The team is doing a lot of thinking right now and exchanging ideas, and it's sort of like a bunch of kids at Christmas, and they open a present and they say, hey, look what I got here, and then they share, and then they go and they open something else up and share the information they're getting.
Dawn will explore Vesta until later this year, and then it's on to pastures new at the solar system's largest asteroid, Ceres, where no doubt we'll be surprised and amazed yet again.
Of course, we can always find more news on the website, which is bbc.co.uk/Sky at Night. And you'll also find their newsletter number 124, which you wrote with Pete Lawrence about what to see in the sky.
Well, thank you both very much. And I'll come back next month. I'll be talking about infrared astronomy. Until then, good night.
And you can see an extended version of this episode on Thursday night at 7:30 over on BBC4.